What's going on, everyone? Welcome back. Patrick here, and in this video we're going to do another example where we have to create a Box-Whisker plot, and we're given the weight in pounds of 10 female tigers in Nepal that was collected over here. So a very similar example that we've done before, but we were making a stem plot in that example. Now we're going to be making a Box-Whisker plot. So first thing we got to do is arrange these weights from smallest to largest. So if we do that, the smallest weight's going to be 156. Next one would be the 180. Then we'll have 192, 194. Then we'll have 212, 216, 234, 242, 307, 354, like that. So notice that there are 10 observations. So the n value is 10, so there's an even number of observations. And so the median, which is going to be the second quartile of the data, is going to be located at n plus 1 divided by 2. So 10 plus 1 divided by 2, which is 5.5. So in between the fifth and sixth observation. So 1, 2, 3, 4, 5. It's going to be between these two. These are the two middle numbers here. So to find the median, we've got to find the average of these. So 212 plus 216 divided by 2 is going to equal 214. You could tell easily that 214 is in between those. So that there is the second quartile. And now we're looking at an even number of observations. So remember, when we're looking at the first half of the data, we got to include that value that was used when calculating the average for the median. And then over here for the second half of the data, we got to include that 216. I mentioned that in the overview video. So notice that in each of these halves now, there are an odd number of observations because there's 5 over here and then 5 over here. And so the first quartile, it's going to be really easy to get. It's going to be this 192, which is the median of this data here. So that's going to be the first quartile. And then this 242, the middle number of these 5 data points, that's going to be the third quartile. And if you wanted to find the interquartile range, which you definitely can, it would be the difference between the third quartile and the first. So 342 minus 192, that would give you 50. Right? So let's make a Box-Whisker plot here. So notice we're going from 156, that's the smallest value, to 354 to the largest value. So I'm going to go up by 50s on this scale here. So if we draw everything, we would start with the smallest value, 156. That would be about there. Then we'll have 192, which would be over here. Then we'll have 214. That's where the second quartile is going to be. So that's going to be somewhere there. Third quartile, 242. Geez, these are all really close together. I didn't even realize. And then 354, it's going to be all the way out here. Okay, so we have to draw a box with lines going through that first quartile, that second quartile, or the median, and then the third quartile, and then whiskers out to the smallest value, and then to the largest value. So that there is the Box-Whisker plot for this data. And if you wanted to take that Box-Whisker plot and show it in a vertical fashion, you could show it like this, where that scale is here, the weight in pounds, same thing as this scale, the weight in pounds went up by 50s, so the smallest value would be down here, first quartile, second quartile, which is the median, third quartile, and then that largest value.